Okay. In the previous session, we clearly discussed about how can we initialize the object. So you can initialize the object using the method or by defining the constructor also. By defining the constructor also, you can initialize the object. Initializing object means bringing value into the object. So to bring the values into the object, you can take the help of method or you can define the constructor. So constructor, defining constructor is the best way to initialize the object. Defining constructor is the best way because when we create the object, constructor will be called. When we create the object, constructor will be called. So it's better to define the constructor to initialize the object. Okay. So even if we define the constructor or not, if we don't define the constructor, implicitly C++ compiler defines the constructor with the default values. Okay. So implicitly C++ compiler defines constructor if we don't define the constructor. If we don't define the constructor, C++ compiler defines the constructor with the default values. Remember this. In today's session, I want to talk about what is static memory allocation and what is dynamic memory allocation. Very important topic. This is useful. This topic is useful to write the data structure programs. So pay attention and listen carefully here. So in today's session, I explain about dynamic memory allocation. So after that, on Monday, I start our actual syllabus data structures. Okay, on Monday, I start our actual syllabus data structures. Okay, so just to remind the C++ subject, I'm explaining all these things. So because these things are useful to write the data structure programs. So in the data structures, I define the class. You may get the doubt, what is class? I create the object. You may get the doubt, what is object? So to avoid such type of doubts, I'm explaining all these things. Okay, so today I explain about dynamic memory allocation. On Monday, I start our actual syllabus data structures. Okay, so listen, pay attention and listen carefully here. So now see what is static memory allocation and what is dynamic memory allocation. You already know it. Already you learned in the first semester and second semester. Once again, I'm repeating. So static memory allocation means, for example, I'm writing like this, int x. I'm writing int x here. So now memory will be allocated at compile time. So allocating memory at compile time is called static memory allocation. Static memory allocation means allocating memory at runtime. Allocating memory at runtime. Sorry. Allocating memory at compile time. Allocating memory at compile time is called static memory allocation. It's called static memory allocation. So allocating memory at compile time is called static memory allocation. So at compile time, memory will be allocated. For example, here I'm writing int x. Now for the x variable at compile time, when we compile the program for the x variable, memory will be allocated. Okay, in the modern C++, just a minute. Yes. In the modern C++, 4 bytes memory will be allocated. So here 4 bytes memory will be allocated. So when we write int x with this statement, 4 bytes memory will be allocated. So how much memory will be allocated now? 4 bytes. Okay, so 4 bytes memory will be allocated. 4 bytes memory. So 4 bytes memory will be allocated. So for this 4 bytes memory location, it gives name as x. It gives name as x. Okay, so after some lines, for example, I'm writing like this. I'm writing x equals to 50. Now this 50 value will be stored in this memory location. 50 value will be stored in this memory location. Okay, once again I'm repeating. Listen. So what happens here? When we write int x, 4 bytes memory will be allocated. So this is 4 bytes memory location. This is 4 bytes memory location. For this 4 bytes memory location, that takes name as x. X is the name. If you write x equals to 50, 50 value will be assigned to the x. Now x value is 50. So in that 4 bytes memory location, 50 value is stored. So at compile time, this 4 bytes memory allocated. So this is called static memory allocation. This is called static memory allocation. Okay, static memory allocation. Then what is dynamic memory allocation? Listen carefully. Dynamic memory allocation means allocating memory at runtime. When the program code gets executed, at that time memory will be allocated. So allocating memory at runtime. Allocating memory at runtime is called dynamic memory allocation. It's called dynamic memory allocation. So allocating memory at runtime is called dynamic memory allocation. So allocating memory at compile time is called static memory allocation. So this is the example of static memory allocation. Allocating memory at runtime is called dynamic memory allocation. Okay. So in C in C language, for dynamic memory allocation, we use functions like malloc function, okay, calloc function, realloc function. In C language, we use functions like malloc function, calloc function, realloc function. Whereas in C++, we use new operator for allocating the memory. In C language, to destroy the memory, we use free function. In C++, we use delete operator. So here this the new delete are the operators. They are used to allocate the memory and deallocate the memory at runtime. So new is called memory allocation operator. New is called memory allocation operator. And this delete is called memory deallocation operator. Memory deallocation operator. Memory deallocation operator. So to allocate the memory in C++, we use new operator. To destroy the memory, we use delete operator. Okay. So new and delete, these are called operators. These are used for dynamic memory allocation in C++. In C language, we use malloc function, calloc function, realloc function for allocating the memory. For destroying the memory, we use free function. Whereas in C++, this new operator is called memory allocation operator. It is used to allocate the memory at runtime. Used to allocate memory at runtime. Okay. Whereas this delete operator is used to destroy the memory. Used to destroy the memory at runtime. Remember this. Used to destroy the memory at runtime. Okay. Once again, I'm repeating. Listen carefully here. So there are two types of memory allocations. One is static memory allocation, another one is dynamic memory allocation. So static memory allocation means allocating memory at compile time. So if you write int x, this is example of static memory allocation. So when we compile the program, 4 bytes memory will be allocated for the x. Okay. And that stores 50 value in that 4 bytes memory location. So at compile time memory is allocated. So it is called static memory allocation. Dynamic memory allocation means allocating memory at runtime. Means when the program is executing, when the program is running, okay, that allocates the memory. This is called dynamic memory allocation. In C language, we use malloc, calloc, and realloc functions for allocating the memory. For destroying the memory, we use free function. Whereas in C++, we use new operator and delete operator. New is called memory allocation operator. Delete is called memory deallocation operator. So new is used to allocate the memory at runtime, and delete is used to destroy the memory at runtime. Then how can we allocate the memory at runtime in C++? Listen carefully here. So for this, we use pointers concept. So pointer variable holds address of the variable of same data type. Pointer variable holds address. You know this. So we take the help of pointer variable because we want to hold the address. So we declare like this: integer pointer p, integer pointer p. I'm writing. Okay. Now with this statement, what happens here? With this statement, for the p, some memory will be allocated. For the p, some memory will be allocated here. For the p, some memory will be allocated. This p is the pointer variable, so that can hold address. That can hold address of which type? Int type only. Pointer means pointer is the variable that holds address of the variable of same data type. Okay, so after this, what I'm writing is, I'm writing p equals to, I'm writing p equals to new int. Okay, here I'm using one operator, new operator. So now what happens here? 4 bytes memory will be allocated now. So now here 4 bytes memory will be allocated. So this is 4 bytes memory location. This is 4 bytes memory location. So for this 4 bytes memory location, okay, assume that first address is 2000. Okay, second byte is 2001. Next byte is 2002. Next byte is 2003. So 2000 is one byte, 2001 is another byte, 2002 is another byte, 2003 is another byte. So this first byte address, okay, p equals to new int means 4 bytes memory will be allocated. After that, first byte address will be stored in the pointer variable p. Means 2000 will be stored in the pointer variable p. So 2000 is the memory location address. So this address will be holded by the pointer variable. So that now this pointer variable is pointing to this memory location. Okay, once again I'm repeating. Listen, if you write int pointer p, this p pointer variable will be created. After that, p equals to new int means new is the memory allocation operator. So it allocates the memory. How much memory will be allocated? So here after new, what we are writing? Int. For int type, how much memory will be allocated? 4. So at runtime, 4 bytes memory will be allocated. So that address is what? 2000. First byte address. Second byte is 2001, 2002, 2003. These 4 bytes are allocated here. So first byte address is what? 2000. First byte address is 2000. That first byte address will be stored in the pointer variable. Now p is pointing to this memory location. If you want to assign the value, we write like this: pointer p equals to 40. P means address. Pointer p means that access this memory location. So in the 2000 memory location, it stores the value 40. Okay. So this is dynamic memory allocation. If you want to destroy this memory now, if you want to destroy this p memory, just simply write delete p. That's it. Okay. I hope you understood. I give another example. So this is about new and delete. That's it. Okay, I give another example to you. Listen carefully. Okay, for example, I'm declaring float f. Float f I'm declaring. Now for the float variable, how much memory will be allocated now? For the with this statement, what happens? For the float, 4 bytes memory will be allocated. Now how much memory will be allocated now? 4 bytes memory will be allocated. Okay, so now this is 4 bytes memory location. Okay, for this 4 bytes memory location, it gives name as f. Okay, so after that, I'm writing f equals to 4.56. Now this 4.56 value will be stored in the f variable. So in the f memory location, that stores 4.56. Now this is called static memory allocation. Now this is what? This is static memory allocation. This is static memory allocation. Okay, now see dynamic memory allocation. For the dynamic memory allocation, we write like this: float. Okay, sorry, just a minute. Yes, float. I'm taking pointer variable p here. Okay, after that, I'm writing p equals to new float. I'm writing p equals to new float. Okay, now what happens here? What happens here? Four bytes memory will be allocated because we are using new. New means 4 bytes memory will be allocated. So new means memory will be allocated at runtime. So this is 4 bytes memory location. This is 4 bytes memory location. So for the memory location, addresses are there. Okay, assume that address is 5000. So 5000 is first byte. Second byte is what? 5001. So second byte is 5001. Third byte is 5002. 5001, 5001, then 5002, 5003. These 4 bytes are allocated here. So 5000 is the first byte address. So this first byte address will be stored in the pointer variable P. So now this is pointer variable P. So in the P, it holds first byte address. First byte address is what? 5000. Means this pointer variable is pointing to this memory location. This memory location address is in the pointer variable P. So now this is called dynamic memory allocation. Now this one is called dynamic memory allocation. So when the program gets executed, at that time memory will be allocated. So remember one point, for the dynamic memory allocation, no names will be there. We use addresses. For the static memory allocation, name is F. Internally, address is also there. Some address is there. 1000 is the address. So we don't know this address. We call this as address of F. So for the memory location, actually name will be there as well as address will be there. But in the dynamic memory allocation, no name is there. With the help of address only, we access. If you want to assign the value, we write like this. We write pointer P equals to, give the value 5.67. Now this 5.67 value will be stored in this memory location. Okay, so hence we store the value at runtime. So this is called dynamic memory location. So two examples I have given. I hope you understood. Okay, so now see it practically. Practically I'm showing. Observe now. Just a minute. I'm opening developer C++ here. Okay, I'm opening new source file. I'm opening new source file. Okay, here I'm writing the program. So hash include IO stream using namespace std. For every program I write it. Okay, int main, starting point and ending point. I'm declaring one integer variable x. Okay, so I am giving x value as 15. I want to print that x value, so I'm writing cout insertion operator x. Okay, now I'm saving this program. Okay, I'm saving this program in our folder cppds humans. Okay, I'm giving this file name as static.cpp. Save it. So successfully saved. I'm pressing F11. Okay, for compiling and running F11. If you want to compile F9, if you want to run F10, if you want to compile and run F11. So directly I'm compiling and running. I'm pressing F11. Okay, so no errors, no warnings. What it is displaying? 15. So what is happening here? Let me explain clearly. So with this statement, what is happening here? That 4 bytes memory will be allocated. For this 4 bytes memory location, name is what? X. Okay, that's it. This is first statement. In the second statement, what happens? 15 value. In the second statement, this 15 value will be assigned to the X. So now X value will become 15. So here we are printing X value, so that prints 15. So this is called static memory allocation. Okay, now see about dynamic memory allocation. Okay, another program I'm writing now. Another program I'm writing. Observe. I'm opening new file. Okay, hash include IO stream using namespace std. Using namespace std. So write int main. I'm declaring one pointer variable here. Integer pointer p equals to pointer p. So then write p equals to new int. Then I'm writing pointer P equals to 45. Then C out, insertion operator, P, pointer P. This is the program. Now I'm pressing F11. Observe here. I'm saving this with the name dynamic.cpp. Okay. Now program successfully saved. It is displaying output as 45. Observe 45. So every program execution starts from main. So program execution starts from main. So with this first statement, what happens here? Pointer variable P will be created. So now this is pointer variable P. Okay. Then with the next statement, with this statement, what happens here? New means memory will be allocated. New means memory will be allocated. So after new, what is there? Int. So 4 bytes memory will be allocated. So how much memory will be allocated now? 4 bytes memory. So this is 4 bytes memory location. So this is 4 bytes memory location. So 4 bytes memory is allocated. So first byte is, assume that first byte is 1000. So this first byte will be returned. This first byte will be returned now. So this first byte will be stored in the pointer variable P. So now P holds 1000. So now this pointer variable P is pointing to this memory location. So this memory location has no name. With the help of address only we access. With the help of this pointer variable P only we access. So with the help of pointer variable P, I am assigning the value. So for P means address. P means 1000. P means what? 1000. In front of that pointer is there. P means 1000. In front of that pointer is there. Pointing to an address accesses that address. So at 1000 location that stores 45 value. So pointing to an address accesses that address. So 45 value will be stored in the P. So now will be stored here. So in the memory location, in the 1000 memory location, so this 45 value will be stored. Here we are printing pointer P. So P means what is the P value? P value 1000. Okay, in front of that pointer is there. So pointing to an address gives value that value at that address. So 1000 memory location has which value? 45. So that 45 value will be printed. So that's why it is printing 45 here. So this is called dynamic memory allocation. I hope you understood. So very clearly I explained every point. Okay. Now listen. For example, in the previous session we created student class. In the previous session we created student class. Okay. So class student we created. Class student we created. So for this student data type, so instead of writing, listen, one more point I want to explain. Instead of writing two different statement, instead of writing these two statements, you can write single statement also. Instead of writing these two statements for dynamic memory allocation, single statement also you can write. Observe here. You can also write like this: int pointer P equals to new int. Directly you can write. Okay. Instead of writing two statements, write single statement also. No problem at all. Observe, just now we have written the program. So instead of writing two statements, I'm writing pointer P equals to new int. One statement I'm writing. Integer pointer P equals to new int I'm writing. I'm running the program. Observe. Now also it is giving same output 45. Okay. So you can write two different statements or single line also. You can write like this or like this also. No problem at all. Okay. So not only for the predefined types, for user defined types also we can create. So for the student type, student S1, we are declaring, this is what, this is compile time memory allocation. So this is what, this is compile time. At compile time, memory will be allocated. Compile time memory allocation. This is compile time memory allocation. Okay, for example, I'm writing like this. I'm writing student pointer S1 equals to new student I'm writing. New student. Assume that this student has two private variables, integer rule number. In the previous session, we have written integer rule number. Okay, string name. String name. Okay. So now what happens here? This is runtime memory allocation. This one is called runtime memory allocation or dynamic memory allocation. This is dynamic memory allocation. Dynamic memory allocation. Okay. This one is called static memory allocation or compile time memory allocation. Static. Okay, so this one is the example of dynamic memory allocation. Observe here. Now what happens at compile time? For the S1, memory will be allocated. So S1 object will be created. So in this, to hold a rule number, memory will be allocated. To hold a name, memory will be allocated. So this memory, this is rule number, and this one is the name. Okay, so for this object, it gives name as S1. So at compile time, memory will be allocated. So at compile time, memory will be allocated. Okay. So now here, what happens here is in the second statement. So this is in the first state, static memory allocation. See, static memory allocation. The dynamic memory allocation, what happens here is a new student. So first that identifies student class members. So memory will be allocated. So now memory will be allocated for the object. So to hold the rule number, 4 bytes memory will be allocated. To hold the name, some memory will be allocated here. So here this one is the rule number. This one is the rule number. And this one is the name. So this memory location's first byte address. Assume that this memory location's first byte address is 5000. That will be stored in the pointer variable. That will be stored in the pointer variable S1. So now this is what now? This is S1 now. Now this is S1. S1 is the pointer variable. So S1 holds that 5000 address. So now it means what? S1 refers to this memory location. So this S1, this object address is in the S1. So this is called a dynamic memory allocation. Okay. So now I'm writing one program here. Observe. So already you know it. Directly I write fastly because less time is there. Only 8 minutes time is there. Okay. I'm writing the program directly. See, observe carefully here. So I'm defining a class. So class name I'm giving a student. So in the previous class I explained this. So student. Observe carefully. Starting point and ending point. Class terminated with a semicolon. So I'm declaring properties in the private section. Int rule number, then string name. Observe carefully here. I'm defining the constructor here. So student int r string n. So to initialize what we write, r value I want to assign to the rule number. So write rule number equals to r. In the previous class I explained. Okay, name equals to n. Name equals to n. So this code we are writing. Initializing. I want to print the details. So I'm defining show method. Starting point and ending point. So write cout insertion operator to print rule number, write rule number. To get 5 spaces, write /t. Then to print name, write name. After that, to change the line, you can write and L. So here above of this, I'm writing hash include. Hash include IO stream. Okay, then using namespace std. Okay, so this is the class. Class is created. Now, so in the previous session, we created object that is static memory allocation. Again, I'm not showing. So int main, in the main, observe carefully here. In the main, I'm creating dynamic object now. Dynamic object. Observe carefully. So student pointer variable. Just a minute. So student pointer variable s1 equals to new student. New student. Now pass the values because here constructor will be called. Here constructor will be called. So pass rule number and name. I'm giving rule number as 10. Okay, and name as Sai. Okay, so now S1 object is created. But remember, so if for the static memory allocation, you called show method like this. You called show method s1 dot show. Okay, but here s1 is the pointer variable, so we write like this pointer s1. So pointer s1 we write pointer s1 dot show. So instead of writing pointer s1 dot show, you can also write like this s1 indirect access operator. So this pointer s1 dot show is equivalent to s1 indirect access operator show. So here dot is the direct access operator. This one is called indirect access operator. In case of pointers, we write like this. So pointer s1 dot show is equivalent to s1 indirect access operator show. I'm pressing F11. Observe carefully here. I'm saving this with the name student1 dot cpp. Just a minute, that is displaying some errors. So define this in the public section. Define the constructor, all this in the public section. Okay, I'm pressing F11. Observe what it is printing. 10 psi. 2 times it is printed because we are calling for 2 times. We are calling show method for 2 times. One is using here we are using dot operator. Here we are using indirect access operator. So the point to understand here is so to access the members, you can use direct access operator or indirect access operator. In case of dynamic memory allocation, we use this indirect access operator. Okay, so this okay, so instead of writing pointer s1 dot show, simply you can write s1 indirect access operator show. Okay, remember this one. So this pointer s1 dot show is equivalent to s1 indirect access operator show. This one is called indirect access operator. Okay, hyphen greater than we have to type. Hyphen greater than is called indirect access operator. Indirect access operator. Dot is called direct access operator. Dot is called direct access operator. Okay, so till now we used direct access operator. Okay, so in the data structures mostly I use indirect access operator. That's why I'm explaining this part. I'm emphasizing here. I'm stressing here. Okay, so this s1 is the pointer variable now. Now s1 is the pointer variable. So to call show method, we write pointer s1 dot show. So instead of writing like this, simply we write s1 indirect access operator show. Okay, now I'm stopping the session here. Okay, so it is printing 10 psi, 10 psi. So this is about dynamic memory allocation. I hope you understood. So so C++ basic classes are over. On Monday, I start our actual syllabus. I explain what is data structures, what are the types of data structures. Okay, and first I explain about linked lists, which are in the second unit. I have sent syllabus to your WhatsApp group. Okay, please check the syllabus. In the second unit, linked list is there. So that part I will explain. So actually in the first unit, stacks concept is there. So after linked list, if I explain stack, you can understand easily. Because stack can be created using linked list as well as arrays. So that's why I explain linked list first. So in the second unit, linked list is there. That part I explain. Okay, on Monday, I start our actual syllabus. Okay, thanks to all. Okay, I'm stopping the session now. Okay, regarding today's session, if you have any doubts, you can ask. You can type in the chat box. I'm unmuting you, or you can ask. Yes, you can unmute and you can ask. Yes. Did you understand today's class? Please, all of you give the response.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Yes, this part is very important. This static memory allocation, dynamic memory allocation is very important to understand the data structures. Without having this knowledge, you cannot understand data structures. Okay. Any
Okay, sir.
doubts? Any doubts regarding today's session or previous sessions? Okay, shall I stop the session?
Yeah.
Okay, yes, I'm stopping the session. Okay, thanks to all. Okay, advance.
Thank you, sir.
Thank you,
Thank you,
sir.
sir. Thank you, sir. Thank you, sir.
Okay, okay, thanks to all. Meet you on Monday.
Thank you, sir. Thank you, sir.
Thank
Okay,
you, sir.
okay, ma, thank you. Thanks to all. Meet you on Monday.
Okay, sir.
Okay.
Bye, sir.
Bye, sir.
Okay,
Bye.
okay.